let's start, have a look on the agenda for today's webinar. Okay, so first we will try to answer the question where fault trees can be used and why we should use them. Then we will look on the features we implemented with our new FTA application. Like all e1ns application, our fault tree module is oriented on the central system model based on a system structure with connecting function network. If failure networks already exist, they can also be used directly when creating a fault tree. Otherwise, the failure networks can also be created via the e1ns FTA module. In addition, I will discuss the interaction of e1ns FTA with the MSR FMEA, and we also have a small interface to the FMEA, so the Fmeter method. Even though we have perhaps only taken a first step here so far, I'm curious to see how you evaluate this connection between FTA and Fmeter, maybe. Of course, we will have a look at the whole thing also live in the e1ns system at the end of this webinar. Okay, so like the FMEA, the fault tree is also one of the tools of risk analysis. However, its focus, especially in a quantitative analysis, is more on the topic of reliability and safety. Besides the preventive approach, there's also a corrective approach for fault trees, but we will only deal with the first one here. So if we compare step 4 of the FMEA, which is the failure analysis, with the fault tree, we will see many similarities, of course, but there are also differences, which we will discuss a little bit later. So what features or what basic features does the e1ns FTA provides us with? So first of all, I said it already, we will be able to create fault trees on a qualitative basis. So really think about gates, about linking failure modes, linking cause and failure relationships. Then we also, of course, can use a quantitative fault tree analysis, adding probability values to our faults within the tree, and then calculate the probability of fail for the top event of our tree. The determination and evaluation of minimal cut sets can be done, and everything I think works easy using a lot of drag and drop functionality. And one important thing is what was also said in the seminar this morning is that we need some inputs for the fault tree. And for example, we can use the system analysis step 2 of the FMEA or the function analysis step 3. And if available, of course, we also can use from step 4, the failure analysis. Like I said before, we also are able to interact with FMEA, with the specific MSR FMEA and with Fmeter. And like all other e1ns modules, e1ns FTA, of course, is also 100% web-based, so you only need a browser to use this new tool. Okay, so let's switch to the next slide. And here we see the central workspace of e1ns FTA. In the center, of course, is the fault tree view. You can see it here directly on the screen. And around, we can see sub-windows up here and on the left side, which we get information of, from which we get information of the existing system model. So it's information from the system structure, function, and failure information. To be able to develop a fault tree over several levels, we need a corresponding system elements with the associated functions. So this data is known to be provided for all the e1ns users with us here via the hopefully known applications like e1ns Architect or e1ns NetBuilder. Unlike FMEA, however, different gate types like are available for failure linkages. So currently the gate types XOR, P-AND, and inhibited are offered in addition to the, I would say, classical gate types, the OR link and the AND gates. However, further specific gates, together with their calculation rules, can be implemented via plugin concept of e1ns in the future. So if necessary, you need other gates than those 5 standard gates we deliver with this version. We could establish more gates with the corresponding calculation rules. The change of an gate can be easily done via drag and drop. We'll see this in the demo later on. So this slide was also presented already in the morning, and it shows us the essential elements of the Ford tree module. And of course, we are able, for example, to limit the number of levels within the tree. And if the number exceeds, the tree is bigger than the limitation here, then we get those transfer gates, which show us that there is a further development with this transfer gate available. We can search, of course, for any entry in a tree. So normally trees are a little bit bigger than the screenshot here. Of course, we have the ability to set up different options for the module. We can recalculate our probability values every time when we did some changes. We can collapse the full tree and so on. Of course, we also can collapse, like it's done here, single branches within the tree. So it's easy for the team to follow where you are working, just to focus on that branch you are really working on. If there is any interaction to MSR, you will see this green marking on the failure entries, which is a hint that there is some MSR interface for this failure mode in the background. And clicking on this bar, you directly can jump to the architect MSR view. We will see this also in the demo a little bit later on. Then all the gates can be identified either by an index, which is just generated on the current tree. And if you modify it, the index may change if you open it another day. But there's also the ability to mark all entries with a fixed ID, which is then the same value in the tree for all the time. And like you see here, we are able, of course, to also for the quantitative analysis to work with these probability values. You can directly enter them into the fields, or you can also use a pop-up window to enter a mass of data in one step. Okay, maybe as we'll see in a moment, directly in the system, not all the elements are available for edit, but also collective entries, like I said, can be made via those pop-up windows. So the classic workflow when creating a for tree in e1ns is based on these following 6 steps. So we should always start with the system definition. It's the same like in FMEA. We should think about the system structure and the function network. Then, of course, we should identify the beginning or the top of our for tree, the so-called top event, which is one of the failure modes from our top system element in the structure. We can create, linking all the failure modes together to create our basic for tree structure in step 4. Then, of course, we are thinking about minimal cut sets, as well as which gates are really needed to link the failure modes and the causes to each other. And step 5 would be integration of probability values and calculation of probability values on all levels. And of course, at the end, we need somehow a result documentation. It could be just a printout of the final tree, but like Karin Ammon discussed at lunchtime, I think in the webinar, there might be some other ways to collapse or to collect all the results necessary for the results output at the end. Okay, as already mentioned, the system definition is done via other e1ns applications. So normally it could be architect, it could be net builder, or as seen here in this screen, it also could be e1ns aspects, our block diagram tool. So there are many ways to set up system structures and function networks within the e1ns software family. So in the next step, maybe one information left here. If necessary, we are always able to add new functions and failure modes also right from the FTA module. That means you do not have to switch. Although switching application is quite easy, but functions and failure modes can directly be added in the FTA module. Okay, for trees can be started at any level of our system structure. Normally, of course, we should start top level, but you can also start developing smaller branches of a full tree, maybe starting on a sub level. So the sub triples from lower levels are integrated directly into the higher level system element trees, and if the corresponding links have been created. The failure mode selected on the focus element will be always used as our top event for the currently processed for tree. So this step 3 shows us, this slide shows us the construction of a for tree by taking over failure entries into a tree representation. So if the failure analysis was already done or started using e1ns Net Builder, for example, you can directly reuse the failure modes entered there and link them to your top level event if needed and if the links didn't exist. So the more detailed the system has already been analyzed before, the faster the for trees can be developed, of course. And since the system analysis and the for tree are closely related, we have also closely connected the related applications, e1ns.fta and e1ns Net Builder, so allowing a very easy switch between these two editors, just clicking on a button. We'll see this in a few moments. So the main difference between FMEA network and for tree is the fact that the network only knows all links between the failure modes. So the FMEA only knows the all links between failures and causes, while the for tree, of course, knows different combinations in the failure levels. And if required, failure causes can also be excluded from the FMEA. So then these failure modes would remain in the tree and also in the failure nets, but they will no longer occur in the FMEA. So with this, you can analyze or discuss, for example, diagnostics and other things within the tree view without having them in the corresponding FMEA form sheet. Yeah, especially when using for trees in connections with reliability and safety analysis, keyword of course here would be functional safety, it is necessary to know the failure probabilities of a top event and to calculate it from the failure probability of the basic events. So for this purpose, the corresponding values are assigned to all basic events within the tree, marked with these green bullets or circle symbols over here. And then the calculations are performed automatically according to the gates used. If necessary, individual failure events and complete failure branches can be excluded from this calculation just by setting what we call stop marks. And with this way, it's easy really to compare variants of the for tree corresponding branches, and so you can compare the calculation very quickly. So as far as the output of the for trace is concerned, we have so far only implemented the saving of the tree views as SVG image files. In addition, there is also a planning for an integrated output of the for trees using our e1ns output module. And for this, we are looking forward to suggestions from you, from our customers, to find out which results of the FTA really should be presented and in which form. One possibility to collect additional information beside the FTA, of course, would be certainly to use the minute form sheets for projects or system elements, and also the initiation of actions via the e1ns actions module can, of course, make the results of an FTA much more valuable. And this slide already shows a little bit from our integration or interface to the MSR FMEA. So the FMEA MSR enables the inclusion of monitoring and response functions in the FMEA work. And however, even these diagnostics can fail, of course, and may not 100% prevent the occurrence of the top event. Therefore, these failures of M and R of monitoring and response functions can now be easily included in the quantitative and qualitative analysis of the fault tree, and we will see how this can work. It's shown here already with this screen over here. You just check the failure modes from failing a response or monitoring function to include them, and then also to include them in the probability calculation. Okay, so let's switch to the last slide for now. So of course, it should be clear to everyone that the creation of a fault tree is not a trivial matter. And depending on the complexity of your system, it can mean a lot of work to do. And nevertheless, it's also clear that the fault trees of similar products should also deliver similar results. Therefore, we've integrated the FTA into our template management system and make it possible to publish fault trees together with other analyses like FMEA, like control plan, or whatever you have in your template with the data templates, and then include them into your projects on the workspaces and adapt them to customer project. So this saves a lot of work and allows us to focus directly only on the specific problems of the new product, and all the basics can be loaded already together with the other template data. So with this, I will now skip or leave this presentation, and hopefully my system is still active. So let me switch directly to the e1ns system. And I just prepared a very small and easy example here. I called it an Airbag system with only 3 sub-elements. We might have a subsystem called sensor system. We might have an ECU. We might have a pyrotechnic system, or the gas generator, and the sensor system just uses 2 redundant sensors maybe in our architecture here, and the ECU is only made of 3 components, which of course in reality is not the case. We have a microcontroller, we have a resistor, a transistor, and maybe our pyrotechnic system just has an ignition unit and a solid fuel system. And so I'm in the net view of e1ns Foundation, and from here, just using the mouse menu, I easily can jump into our editable net builder view. And from here, you can see all, or you can prepare your system, you can create your functions network out of it. If you want, you can also start discussing your failure network and so on. And let's just move to the top level. So I'm loading the Airbag, which is my top system element, here in this net builder view. And you can see it's very easy to jump from net builder to e1ns FTA just by using this edit with e1ns FTA button over here. Of course, you can also call the FTA module directly from the main menu. It's found here in the list, e1ns FTA, but this one is a quite helpful button. Just click on it and you automatically load the selected failure mode if it's done already, loaded as a complete fault tree according to this top level failure. Again, of course, We saw this screenshot a little bit in the presentation already. There's also always access to the structure tree here to the left, so you can also use the structure tree for navigation, like you are familiar with other modules. But I think this is not needed because for our Airbag system, we have this subsystem window over here where we directly can navigate to those elements we would like to take data from and to work with these elements. But before we start editing new data, just to show you, you can limit the number of levels very easily. So maybe just collapse it to one level, then all the others get a transfer gate. But double clicking on a failure mode will open the corresponding sub branch, and you can directly edit the sub branch if you want, and then go back to the next higher level. And if I now go back to the maximum number of levels, then of course I can be sure that the full tree is always loaded completely. You can also enter search terms, especially in big or complex for trees, to find the corresponding values. And there's a lot of options available. You can choose. We will come back on some of them a little bit later. So now let's think about, so I selected one of the top level failure modes of our airbag. So the function is that the airbag activation should only be there in case of demand. And yeah, we just discussed with this tree here, the airbag is activated unintentionally. And of course, there might be another failure mode which was not discussed, and maybe the team says, okay, what about that the airbag is not activated on demand? So it's easy for us directly using the mouse menu, for example, to create a new top level failure mode. So I'm in the focus element, that's the loaded element, and I just add a new failure mode, and it should be, let's say, airbag not activated on demand, maybe. So that's the, maybe we should add the E here as well, so that the system is, yeah, thinks everything is all right. So the airbag is not activated on demand. This could be our main entry, so you can move it also and place it somewhere else on the drawing field here in the drawing field. And now the question, of course, is for people working on a failure mode, why or what is leading to this problem? So what are the causes which could be there? And therefore we could navigate through our system, and maybe from our pyrotechnic system, of course, the already known failure that there's no inflation of the airbag could be one of the causes we would like to link. So if you want to link a failure mode with an existing entry in the tree just by drag and drop, we learned it already, put it here and drop it here, and then of course the failure linkage is created. And because this one was already discussed in the main for tree I showed in the beginning already, the system already knows reasons why there's no inflation of the airbag. So it could be an ignition fail from the ignition unit, which is one of the sub elements here, or it could be a gas generation too low problem from the solid fuel here. And of course, it's not only using existing data. Of course, there could be a problem coming from this sensor system, for example. So let's see what is already listed for the sensor. So wrong data detected or wrong data transferred. I think both does not really fit to not activation, but maybe we can add a new failure mode here. So the same here, using the mouse menu, just add a new failure mode, which could be just that no data is transferred. So therefore, I just, not transferred, but transferred with an A. And I can add this one if I want. I directly can add the next one, but I will take this one and link it just by drag and drop. And you can see the tree is now updated with this new entry over here. Of course, here, this is a completely new failure mode. We didn't discuss it, but of course, then the team might say, okay, why we do not transfer? We discussed something similar for the sensors. Let's take a look on the sensors. We have sensor number 1, and we have already a failure mode from the sensor called a transfer failure. So maybe the team says, yes, let's link this one to this failure entry here as well. And the same for the redundant sensor, where we have the same failure available. So just by drag and drop, I can now create this one. But as I said, these sensors are redundant, and this is now, of course, a specific thing FMEA cannot do. Is the question, answers the question, what happens if only one of the sensors fails? So nothing will happen. So the for tree, of course, then can say, okay, then let's not use the NOR gate, which is the standard gate used here. Let's use the AND gates, which means I just by drag and drop exchange the gate. And if you can see, this update button already gets orange here, which reminds me changing the gate will lead to new probability calculations. As you can see here, my tree has already probability values in it because I did some analysis before, and therefore the system knows some basic event probabilities, and if they are known to the system, they are reused automatically and calculated. But now changing the gate type leads us to new calculations, so we have to update this one. And maybe you took a look here, now we have a much lower probability, because only if both sensors fail, then of course we will really have no signal, and then the Airbag system might also fail here at this time. So this just as one short idea of generating data. And of course, if you want to change any of the basic event probabilities, you can easily do it just by clicking directly in this field. So with this, I can directly lower, for example, the value here, confirm with enter. Again, I am asked to reload my tree. So I can enter some more changes first and just do one reload. In the beginning, we thought we automatically would reload, but for complex systems, maybe that's a question of performance. Therefore, we said we just recalculate on demand. And of course, if you have a big tree with a lot of functions, a lot of probability values, it might be not a good idea really to click from cell to cell. It's better to edit things like this in a form sheet. Therefore, we can, for example, select the top level, and from the mouse button, we have the edit probabilities command here. And then we get a full list of all probabilities, and we directly can work in it, like in the methods form sheets you are familiar with. We directly can edit values here. We can use filter functionality and so on. Or if I do it on the bigger way, of course, I also get a list of all the events from the basic events underneath my top event here. So going back to this one, we also see that there's one specific or one special failure mode. And as I said before, if we see this green bar over here, we can see that there is somehow a safety mechanism behind. So this was already analyzed within our MSR functionality in e1ns Architect. And when I click on it, the system automatically jumps to e1ns Architect. And what is going wrong here? My system does not load. It should load. Let me go back and see what has happened here. Maybe I was too fast and I didn't open it correctly. So sorry, I double clicked. So it just opened it as a sub element. Now I just clicked it once and the system really jumps from the entry in FTA to the architect module. And here you can see that we decided that this failure mode from the ECU, which is the wrong acceleration calculated, could be monitored by a specific microcontroller function, for example, to execute a plausibility check as a monitoring. And if there's something wrong, to set the system to a safe state. But we also know that if this happens, we can do this here in write in architect, or we can do it also in the for tree. If we have those functions for the microcontroller, they can go wrong. So I also added already a failure mode here, so we could have an error in plausibility algorithm, or we can also have a fail of the safe state, and safe state fails here. And when I'm going back to my FTA, and let me, maybe go back to the top level again. So I'm focusing here on this tree. You can see that I included already these values, which are failure modes coming from, or which describe the fail of our diagnostic, our monitoring function, which is this one, and the fail of our response function over here. And I integrated it. So I used them with this AND gate here to lower the calculation. And the question is how, what is the likelihood, of course, or what's the probability that the safe state fails? Just some fantastic values here from here. I have no idea if these are real values, which really make sense. And I did the same here. So I included all of them here. So they are now part of my for tree, including the diagnostics. But as I said before, maybe I want to compare what is the situation without these diagnostic systems. And this can easily be done without creating a new failure mode out of it. I can just use what we call the stop marks. And therefore, first of all, I have to activate this one by calling this command, consider stop marks over here. And if I do this, I should also highlight the stop marks in the tree. And if I set them, for example, excluding these two errors, so this one, the response error, I set a stop mark here, I set a stop mark over here, and the system already warns me, please recalculate and take a look on this probability of this AND gate here. If I update it and if I exclude it, I have now a much higher probability when no diagnostics are in place. So with these stop marks, and of course I can easily decide to remove the stop marks again, and with this then the corresponding values go back, and the likelihood or the probability is lowered to a much smaller value, of course, at the end to lead to a smaller top level event probability. So without really changing the tree, just using stop marks, I can easily compare different situations in the tree. So I think this is a very helpful tool. Talking about excluding data, of course, it might, like I said in the beginning, it could be a good idea to say, okay, safe state failed, and the error of the algorithm should not be part of my ECU FMEA. So normally now they are part of the network of the tree. So they normally would be, of course, occur within the FMEA. But it's easy for me to exclude them there just by select this command over here. So I say, let's exclude both the safety mechanism, safe state problem, and also the diagnostic problem. Let's exclude both from FMEA. So these entries are marked with these black triangle symbols over here. And when I now switch to my ECU, and let me switch also to the FMEA. So let's check. I just used the team FMEA. That's the easier form sheet for me to load. And here you can see now only 3 values are really used in this tool. So when going back here to the fourth tree and now include them back into the FMEA, and going back into this one, updating my form sheet view, of course, these will be also part of my FMEA form sheet, and I can go on and discuss preventions. I can enter my evaluations and what else is needed at this time. So it's very easy to exclude data from the for tree, which should not be, maybe not be discussed in FMEA. And the last thing I want to show is that if we have these values in the tree, it might be that already an Fmeter was calculated or was performed on the ECU, for example. And in this case, I did a very small one, but I did one. So it's possible then to directly to read the FITs, the failure in time, the fit values from the Fmeter to show them in the for tree. That's of course a very first integration of Fmeter data, but it is easy to show. So we just show fit values, and if fit values are existing because there is an Fmeter calculation existing, we can directly see them in the tree here for these three values coming from the Fmeter. And to see how this looks in Fmeter, maybe I just switch to the functional safety Fmeter according to the 26262 ISO norm or standard, sorry. And let me open this one here. Hopefully it does not take too long. Come on, why it's taking so long to open this Fmeter? I do not know. Maybe I have a connection issue with the server system. There we go. And here we can directly see that I performed a very small Fmeter on this ECU. So where the controller resistor transistor were discussed, where the failure types were selected. And with this, we got a failure distribution. We entered some fit values for the three components here for the controller, the resistor and transistor, but they were of course then distributed on the different failure modes for the Fmeter. So therefore, the drift failure or the closed failure is just a fit value of 0.2, while the open circuit is 1.2. And exactly these values are shown here directly within the for tree. So this is a first interface between for tree and Fmeter, and I think in the future we are thinking about a better and deeper integration. But of course, here we are directly in contact with you, with our customers, to find the best and the most sensible, reasonable integration between these two methodologies. So maybe at the end for the quality qualitative let me go to the higher level for the qualitative FTA. I said that it's of course important to know what are the minimal cut sets. So what is really needed in minimum to happen that the failure, the top level event really happens. And we just implemented a very handy way to show all the minimal cut sets. They are always shown for the complete structure you selected. So if I'm on top level, I just can see the list of all the minimal cut sets. And for example, here I can see for cut set 5, only if I have these 5 in place, then I really will get the corresponding top level event to happen. And with this, it's quite easy. So here, of course, depending on OR gates, AND gates, and so on, the cut sets are directly derived from our for tree. And at the end, if I have this for tree, and if I think, yes, that's a good for tree, we finalize it, we want to document it somehow. Like I said, at the moment, we offer you a easy way to save this one as a SVG file, just clicking on it, and it will be automatically exported, and you can open it, for example, in a browser or in any document or in any program, being able to open these SVG files. And of course, like we always do with important outputs, you can also, for example, and I did this with another example here, you can directly put your image file directly to your Airbag system as a document in e1ns documents. For example, I generated this one. You can see it as a preview. You can reopen it. You can use the release process or approve it here with electronic signing and so on. So then you can make it an official for tree if needed directly in the e1ns software family. So that's the end of my things I wanted to show in the live demo. So let's go back to our PowerPoint. Let's switch to the summary here. And with this summary, I would thank you very much for your attention. I hope I could bring you a little bit closer to our newest tool of the e1ns family and show you how we integrated it into the existing system model